Welcome to our channel Storm Rider. The 2026 evolution of the USS Zumwalt DDG-1000 is one of the most interesting chapters in the story of modern naval engineering, and in this video we're going to explore the ship in deeper detail than before, looking closely at its design philosophy, performance, electronics, weapons, sensors, and long-term strategic role. At first glance, the Zumwalt looks unlike any traditional destroyer. Its hull is shaped with an unconventional tumblehome form, meaning the sides angle inward as they rise. This dramatically reduces radar cross-section because flat, angled surfaces send radar waves upward and away rather than bouncing them back to the source. In simple terms, a 600-foot ship appears more like a small vessel to enemy radar, which helps the Zumwalt operate closer to contested coastlines or inside surveillance-heavy areas while remaining harder to detect. The superstructure is built using faceted panels similar to stealth aircraft principles, and almost all antennas, sensors, and communication arrays are either recessed or fully enclosed. Even the exhaust system is designed to mix cooler outside air with hot gases so that the ship's infrared signature is reduced, helping it hide from heat-tracking weapons or drones. Beyond stealth shaping, the hull itself is made using advanced composite materials that minimize magnetic signature, another important factor because certain naval mines and detection systems rely on magnetic field disturbance to identify passing ships. The design reduces both radar and magnetic visibility, making the Zumwalt one of the stealthiest surface ships ever deployed. In terms of raw power, the Zumwalt runs on an integrated power system capable of producing around 78 megawatts of electricity, far more than traditional destroyers, which gives it a major advantage. Instead of having separate mechanical systems for propulsion, weapons, and electronics, the Zumwalt uses a unified electrical grid. Gas turbines generate power that is distributed across the entire ship as needed. This is why the Zumwalt can host extremely energy-hungry systems like its Spy-3 radar and advanced computing core while still having leftover capacity for future upgrades like high-energy lasers or electromagnetic weapons. The propulsion uses advanced induction motors that allow the ship to move quietly and smoothly, reducing vibrations and acoustic signature. This is especially useful for anti-submarine operations because submarines rely heavily on listening devices to detect surface ships, and the Zumwalt's quiet electric drive gives it an edge when operating in areas where stealth is critical. Even though the ship weighs more than 15,000 tons, it can reach speeds above 30 knots, and its hull allows smooth handling in rough seas. Early concerns about tumblehome stability were largely solved by onboard stability software and improved ballast control, giving the modern configuration much more confidence at sea than in early trials. Inside the ship, one of the biggest advancements is the highly integrated digital combat system. The Zumwalt is sometimes described as a floating data center, because so much of its capability relies on computing power. Crew members operate using large touchscreens and multi-function consoles that allow them to switch between navigation, weapons control, sonar, radar, and communications with just a few inputs. Automation significantly reduces the number of crew required. Where older destroyers might need 280 to 300 sailors, the Zumwalt operates with closer to 140 to 150 in normal conditions. This means more efficient operations and a lower chance of human error in high-stress environments. The ship's internal networks support advanced decision support software that can analyze threats, recommend responses, and manage multiple simultaneous engagements faster than human operators alone could. It doesn't replace human judgment, but it enhances it, giving the crew clearer information and quicker processing of complex situations. Weaponry is another area where the Zumwalt stands out. Originally, the ship was built around two massive 155mm advanced gun systems that were designed to fire precision long-range rounds over 60 miles. However, the specialized ammunition became too expensive to continue developing, leading the Navy to repurpose those systems for potential future use instead of active deployment. By 2026, the ship's main weapon loadout centers around 80 vertical launch system cells embedded along the sides of the hull. These cells can launch a wide variety of weapons, including Tomahawk land attack missiles, evolved Sea Sparrow surface-to-air missiles, anti-ship strike missiles, and other advanced payloads depending on mission requirements. This modularity gives the Zumwalt the flexibility to shift between land attack, surface combat, and fleet defense roles. The ship is also designed with future energy weapons in mind. With the immense electrical capacity already built into the hull, the Zumwalt is one of the only current ships capable of hosting scaled-up laser systems without major redesigns. Lasers provide advantages like low-cost ammunition, incredible accuracy, and near-instant engagement speed. Although full-power lasers may still be developing, the Zumwalt's readiness for them adds long-term value. The sensor package onboard is equally advanced. The primary radar is the SPY-3X band multifunction radar, which excels at tracking air and surface threats with very high resolution. It uses electronically steered beams, meaning it can shift focus extremely fast without moving mechanical parts, allowing rapid detection of small, fast-moving objects like drones, incoming missiles, or low-flying aircraft. The ship's integrated sonar system is optimized for submarine detection and underwater threats, combining hull-mounted sensors with towed arrays. For air operations, the Zumwalt can support multiple MH-60R helicopters or unmanned aerial vehicles, expanding its reach far beyond line of sight. These aircraft can scout targets, track submarines, or provide early warning of incoming threats. A major strength of the Zumwalt is how seamlessly these sensors integrate with its computer systems, which allows it to track and prioritize multiple threats at the same time with a high degree of accuracy. When it comes to daily life on board, crew habitability is a big improvement compared to older ships. Because of its large internal volume and modern layout, the Zumwalt offers quieter sleeping quarters, better lighting, improved air filtration, and more ergonomic workstations. Reduced mechanical noise from the electric drive also makes the environment less stressful. These may seem like small details, but they make a big difference during long deployments. A comfortable crew is more alert, healthier, and capable of maintaining high performance during prolonged missions. Strategically, the 2026 Zumwalt represents a blend of advanced technology and adaptable mission capability. It is not built to replace traditional destroyers but to complement them by handling specialized missions that benefit from stealth, high electrical capacity, and advanced electronics. Because it is harder to detect, it can operate closer to enemy coastlines, gather intelligence, or deploy weapons with less chance of being countered. It also serves as a test platform for next-generation naval systems, meaning lessons learned from the Zumwalt feed into future ship designs. Critics often point to the high cost and limited number of ships produced, but supporters argue that major technological leaps always begin with smaller fleets, and the innovations introduced by the Zumwalt class will influence naval warfare for decades. Its value lies not just in combat performance but in its role as a stepping stone toward a new era of naval